Good afternoon, everyone. Today we're going to do Chapter 5. And in Chapter 5, the topic is probability. 5.1 is the introduction to probability. And then there's some probability rules we'll get into in the later sections of 5.2 and 5.3. But right now we'll just start off with the introduction of probability. Idea of the likelihood that things happen. Let's just start out with just a basic example. I've got 3 red marbles and 7 blue marbles, and they're in a bag. And I just shake up the bag, right? And they get all random. And my question is, what's the probability that I select? I'm going to select one marble, a red marble, from the bag. And that's what we're going to answer. We're going to answer that question. What's the probability that I select a red marble from the bag? I'm going to select the one marble, pull it out. Well, what's the probability it's red? And so with probability, we always write these fractions. Everything's a fraction. What do you think goes in the denominator?
10.
Yes! The total number of events in this sample space. That's how they say it. Yeah, so there's 3 red marbles, there's 7 blue marbles, there's a total of 10 marbles, right? I'm going to put that in my denominator. You can just put 10, but you think there are 10 marbles possible. Alright, 10 total marbles. And the way we say in statistics with probability here, the way we discuss this, we say, you know, the sample space. There are 10 elements in the sample space, and that's the number that goes in the denominator. What goes in the numerator?
3.
3. The number of red marbles possible out of the 10 marbles. So we get 3/10. And you could actually leave your probability solution as 3/10. But some of you like to write it as a decimal. 3/10 is
33%.
0.3.
3.
Now, if you write that in terms of percentage, is it 3% or 30%?
33.
That'd be 30%, right? So when 3 out of 10, 0.3 is also 30%. Well, all these are fine. But make sure for this, so when you take that 0.3, you can move the decimal place 2 places. Some of you just figure out, well, I'm going to take that 0.3, multiply 100, you do that too. Just be careful though. 0.03 is 3%, right? 0.3 is 30%. So hey, just real quick, that number, what percent is 0.5? 50%, very good. That would be 50%. Whereas 0.05 is only 5%. And my goodness, what would 0.005 be? Yeah, very good. Did you hear that? Outstanding. You said 0.5%. But you can leave your answer as 0.005. You can leave your answer as 0.5. It's just when you write your solution, you can actually write it as 3/10 or a reduced fraction. 7 out of 24. My odds of winning the lottery, 1 out of 1,000,000. Right? You can write it that way. But just be careful when you're writing it in terms of percentage or just writing it as a decimal. One other thing, we're going to start seeing these types of numbers appear more often in this course. Is numbers like this. I'm just going to write 3.022. And so that can't be a probability. That can't be a probability. The highest probability possible is 100%. Right? Yeah, we know there's things in this world that can like increase over 100%. When we're talking probability, the highest possible is 100%. Well, what we were just talking about, wouldn't that be 300%? So yeah, that's not a probability, but you're going to see numbers like this occur more and more often, and they're going to emerge on your calculator. These are going to be your probabilities. So this right here, when you see this on your calculator, this is in scientific notation. All right, so I wish they highlighted this on a calculator, but it'll be sitting at the end of the calculator. So 3.022, maybe some more numbers, e negative 4. That means 3.022 times 10 raised to the negative 4. Which also means, when I've got a 3022, and that decimal point that was right here moved 4 places that way. So what I'm going to do is I'm just stick some zeros in front of here. Here. I'll stick too many, but the decimal place that was right here, it moved that way. How many places?
4.
So it starts here, I'm going to go 1, 2, 3. Oh, there it is. So let me make a big dot. Take all these off. So really, that number right there is 0.0003. A very, very, very small chance, right? I mean, that's the odds I get in an accident today, right? On my ride home. It could happen, but, you know, we're hoping it doesn't. Those are my chances. So it's just a very small probability. So would you look out for that? Now when you're looking at your calculator, look at the end. Look at the very end. Who's got the newer calculators? Some of those I like that they, the screen, it actually shrunk it a little bit. You can spot that a little bit easier. So just be looking out for that. You'll know, you say, you can't get 300%. So very good. I guess what's an easy way to do this? If you see negative 4, then how many zeros will be before that 3 after the decimal point? 3, right? So if that helps. So if you had this number, 6.22 e negative 5, well then I'll just put a decimal point. If you want to write this in decimal formation, that means there would be 4 zeros after that decimal point, and then that number 6. Does someone see that? 4 0, negative 5, 3 zeros, negative 4, if that helps. The key is, you know, they're very small numbers, aren't they? Just know that. They're very small probabilities. Some of you take chemistry. I think you've heard of 6.022 times 10 to the negative 23rd. That number is puny, right? Yeah. All right, so I'll erase this. All right, so I'm going to put on the board a probability model. Or excuse me, we're going to create a probability model from a frequency distribution. That's what we're going to do. So I'm going to pull a frequency distribution from section 5.1. This is on page 267. And I'm just going to create this probability model with you. But what I'm writing on the board right now is just a frequency distribution. This is actually problem number 38. All right. Number 38. They've got age 15 to 19-year-olds. All right. 20 to 24. 24 to 29. 30 to 34. 34 to 39. 40 to 44. 45. They went all the way up to 54 with this last one. Okay. Those are 8.
Professor, that should be 25 to 29.
Oh, thank you so much. Well, that's a 25 to 29. Thanks again, Art.
No problem.
So these are the ages. Over here, we have the number of multiple births. Cool. Oh, Brianna.
Wasn't it the same down there? It should be 35 to...
Ah, Brianna, thank you. I didn't do it anywhere else, did I? Let's see. 35 to 39. Thanks, Brianna. This is the number of multiple births. And by this term, multiple births, they're talking about those individuals who had at least 3 kids or more, triplets or more. So we're not talking about twins. So if someone had twins, all right, now that could be multiple births, right? Multiple, two at once, but we're talking about triplets or more. All right, and here come the numbers. This is a frequency distribution. We've seen plenty of these, 100, 467, 1620, 2,262, 1,545, 328, 105.
Is that per 100,000?
What was that?
Is that per 100,000?
500,000.
Number of model 3 or more bills. It don't tell you that.
No. Hey, this source, everyone, this was National Vital Statistics Report in August of 2010. So it is national, so they're talking about the United States. These are multiple births, United States, 3 or more babies at once. I'm curious, anybody in the class knows someone who's had triplets? Anybody? Isn't that interesting? Doesn't occur often, does it? Because we all have friends and know people who have had babies, of course, right? We know people, but no one in this class seems to know someone who had 3 babies or more at once. I know one person. I only know one person. I had triplets, actually. Hey, come on in there, son. So these are multiple births. What we're going to do is we're going to construct a probability model. All right. And we're going to construct a probability model. All right. The good news is you're going to know exactly what to do. You and I are going to put the probability model right next to this. And you already know how to do this. Because you did something like this on test 1. Do you remember relative frequency?
Mm-hmm.
I'll say it again. You remember relative frequency with the percentages? That's what we're going to do. It's going to be the same step-by-step procedure. Cool? So we're going to come up with these percentages. Just, okay, what's the likelihood, a random person who does have multiple births, in the future, you could say what's the chances that that person would have that. All right. So let's come up with these here. Hey, for our class presentation here, when we come up with these, at some point, the calculator is going to write these decimals out to many places, right? Mm-hmm. How about each one of these, we'll round to 2 decimal places. That's what we'll do. We'll round each one of these 2 decimal places, and then we'll just make sure everything adds up to 100% because we'll be rounding in there. So, what's step 1?
Add all of them.
All right, we got to add them up. We're going to sum all these here. I'm going to put that down. That's that summation symbol.
6427.
I hear 6427. And Holland verifies that. Thank you, both of you. Everyone, they're getting 6,427 for the sum. That's the sum of all these. Now, we just want to make sure we don't do this backwards, right? I'm going to type this on my calculator. Do I type 100? Then I hit the division sign?
Mm-hmm.
And then the 6427, or vice versa?
Yeah.
I'm going to type it like that, right? Oh, good. So that's how we're going to type it on our calculator. What comes up? Just give me like the first 3 numbers after the decimal place.
0.015.
0.015. What do y'all think? If I'm going to estimate that round it to 2 decimal places. What do you want to do? Want to do 0.02? Will that work? Awesome. Hey, could I have rounded that down to 0.01? Yeah. Could you leave it 0.015? Absolutely. Absolutely you can. But